Hi, good afternoon. My name is Bob Cleveland. I'm going to talk about nuclear safety through quality assurance practices. This will be a different talk than what you've seen. I'm primarily focused on pressure transmitters that are used in the containment structure for safety applications. So I'll give you a company overview. Emerson is not a big name in the nuclear industry, but there is a division of Emerson called Rosemont Nuclear Instruments that has been focused for over 30 years on the nuclear industry, and that is the division that I work in. I'll give you a little bit of background about Rosemont pressure transmitters, and then talk about the qualification standards that we use to test our products for safety applications in nuclear power plants, the quality assurance program that we use, and then some of the quality assurance practices. So Emerson is a large company based in St. Louis, Missouri. It's founded over about 120 years ago, represented in more than 150 companies, 255 manufacturing facilities, and last year was over $21 billion in sales. The Rosemont division, which is a well-known company throughout the world for process instrumentation in all kinds of industries, is located outside of Minneapolis in Minnesota. This is our headquarters. Last year's sales this year expected to be about $1.9 billion, about 5,000 employees worldwide. This facility itself has about 1,200 employees. The Rosemont Nuclear Division is located in this facility. All the nuclear safety instruments that Rosemont manufactures are manufactured here. Globally, we have a large presence. Manufacturing is primarily centered in the U.S., Germany, Singapore, and China. We have a new facility located very close to here. I'm not sure if I'm going to pronounce this right, at Bhuwani in India. It's a growing facility. Our business is, the last few years has been growing 15 to 20%. So we have a large presence here. I don't know the total number of employees, but it is growing, and it is in the thousands. Now I'm going to talk a little bit about our products, and this is a nuclear safety pressure transmitter. So this would go inside a containment structure. What we do is we take the technologies that are available commercially and we adapt, modify them for nuclear safety applications. Enhancements for developing seismic robustness, radiation resistance, and resistance to steam and temperature in a local event. One thing that I always mention is that our products are a bit of hardware, which is our transmitters, but then they're only as good as the documents that support those products, the testing that we do. So these transmitters that you see here are installed in over 200 reactors worldwide, 20 different countries, and in every type of operating reactor. I shouldn't say that. Fast breeders, we don't have any installed base on yet. You can talk about that. A little bit of history, I'll go quickly here, but the Rosemont pressure transmitter, which was the basis for the success of the company, was first developed in 1969, and then it's gone through several iterations and improvements, mostly in the air, some mechanical improvements as well as microprocessor additions in the early 1990s. The nuclear pressure transmitter history actually started with General Electric on the Model 1151, which Rosemont introduced in 1969. So General Electric came to us and said, how do these transmitters do in radiation? And out of that, in 1975, Rosemont introduced its first fully qualified nuclear transmitter, the Model 1152. As the U.S. nuclear industry developed, so did our products. And you can see here, the 1152 started introduced in 1975, up to the 1154H, which was designed primarily for the CE, pressurized water reactor, for the pressurizer pressure and pressurizer level applications. So that was about a 20-year development, and each iteration increased the performance, improved the performance primarily for temperature, radiation resistance, and seismic robustness. On the right-hand side, you'll see a new line of products that we started developing about 5 or 6 years ago. The main focus of these will be on the new reactor technologies coming out so from General Electric, Westinghouse, Areva, and they are still under development. We have completed the 3152 model that's fully qualified for the French plants and for the U.S., the new designs from the U.S. Our products will primarily go into the containment. This is a pressurized water reactor, so all the main applications inside containment, our transmitters are installed on reactor coolant flows, pipe pressures, pressurizer level, pressurizer pressure, as well as applications outside of the containment structure that have a safety designation. That would be primarily seismic. Inside containment would include radiation and the steam temperature local profiles. The standards we use, primarily the two big ones in the world right now are the U.S. IEEE standards for qualifying electrical equipment for safety applications. That would be IEEE 323 and 344, which I've had several conversations with MPCIL. I think these have been used as the basis for the qualifications that have been done in India previously. And then the second one would be the RCC standard from France, and has followed the French technologies as it's expanded throughout the world. When we qualify a piece of electrical equipment, we look at basically four things. What are the service conditions? The normal and abnormal, and then also the design basis event, the accident conditions. What the equipment is going to be interfaced with mechanically and electrically. The qualified life, how long we want this piece of equipment to operate in a reactor and still be able to perform its safety function. And then what exactly is the safety function? So I'll just briefly go through what we do. These would be for the accident conditions, the design basis event. The first one would be seismic. That's a seismic table, shaker table that would rotate 3 axes that we put our transmitters on. They would be mounted to a wall surface, a flat surface, or a pipe mount. And then the profiles would come from the plant itself. Each plant, depending on the location where it is, the safety analysis that was done will develop a profile. So then we have to test our transmitters to be able to survive that profile of that particular plant. Radiation testing there in the scent chamber, and then we blast them with steam and follow a profile again coming from the plant maker that's inherent in their design. Quality, this is our quality policy. Customer satisfaction is the key. Our organization focuses every day on quality and safety. That's what we strive to do, and everyone has to understand that and participate in that. We have a very robust organization. We've grown tremendously the last 10 years. We've gone from about 40 people to about 75. The recent growth has been the China nuclear market, which we've been very successful in. So quality culture throughout the whole organization is for, we will see that the quality manager is its own area, reporting directly to the executive, and that's a key part of the nuclear safety. Our quality program is based on 10 CFR 50, Appendix B. The 18 elements of that also work. We do enhance that to meet some special requirements from, say, RCC requirements or ISO, the Canadian standards. So, but the basis is the 18 elements of 10 CFR 50 Appendix B, and then we enhance that with other requirements as necessary. And then the second part is the Part 21. If we find any kind of non-conformance that may inhibit our equipment from performing its safety function, we are required by law to tell our customers. That's a U.S. law, enforceable in the U.S., but Rosemont Nuclear applies that to our customers worldwide. So, if when we are selling our transmitters in here and we do have an issue, you will be notified under the 10 CFR Part 21 basis. So, I'm moving quickly through the conclusions. Quality assurance for safety. All the testing we do to make sure that our transmitters perform according to their published specifications in normal conditions. That would be the accuracy of the instrument, temperature effects, so how it reacts to changes in temperature, static pressure effects, the drift of the instrument. And all these things are specified in our product data sheets. And the testing that we do ensures that we are meeting our published specifications. And then, of course, the accident. Accident conditions are a little bit more difficult, as you can probably imagine, to test for, but we do periodically test our instruments to ensure that they will perform according to the documentation in accident conditions. In conclusion, quality assurance practices. I broke this down into 4 groups: product quality, supplier quality, the product certification quality, and then a couple of other little additions. What we do at Rosemont Nuclear is we've established production excellence teams to monitor the data and any discrepancy reports that may come up, and to focus on those to ensure the quality of our products. Product verification would be primarily audit testing that we do with our products internally and also with third parties. Statistical process controls, we utilize those to ensure that we're meeting our specifications. Inspection and test, everything from individual components to sub-assemblies to final assemblies. We have testing in place to ensure that the final product meets its requirements. Failure analysis, that's if we find something in our internal testing during manufacture, we will check that out very thoroughly to make sure that non-conforming parts don't get into our products. And then the second part of that, and the big part of that, is if customers have an issue and they send it back to us. We do very thorough failure analysis and issue reports to make sure that we're keeping the products in performance and meet the safety requirements. Customer factory acceptance tests. We're running, a tremendous amount of customers coming through our plant the last few years, and we learn a lot from them. Communication for supplying safety-related instruments with our customers is critical. We want to talk to you from the very beginning all the way through ongoing communication. We encourage visits to our plants. We listen to feedback and develop action plans from those. And then internal audits that are regularly scheduled through our quality assurance program that go on regularly. Supplier quality, this would be the same thing that we do through our product quality and checking everything that comes in, any issues are addressed. We have a goal, a requirement of visiting all our suppliers once every 3 years. We do that more frequently if we have some issues or special needs. And then in closing, we do send out customer surveys once every 3 years. We try to survey all of our customers worldwide, understand what they're seeing, what their issues are, and how we can improve. And quite often, customers come to our plant to perform various different kinds of audits to quality assurance programs. And then as far as Fukushima and our instruments, we haven't felt any impact yet. We have had a lot of requests for measurements on spent fuel pools and backup water tanks that traditionally were not safety related, and now post Fukushima, the regulators are addressing that. And so we've had quite a few inquiries about how would we could help to improve that. So thank you.